In today's lecture, we will discuss about hypothesis. Now, we started our research journey from a research problem. Whenever we have research problem in mind or some research idea or some research concept in mind, we think of working on that research problem or research concept. We try to find out solution to that research problem or research concept. And for that reason, we undertake this research process. Now, first part of research process is your research problem. We have already formulated research problem in the previous lectures. Now, once you formulate your research problem, the next step in this process is to identify the variables which are associated with your research problem. So in the previous lecture, we discussed about variables of your study or variables which are essential for your research problem. That is also done. Now, once you identify the variables, the next step is you have to identify measurement scale. Like for each variable, we have to measure the variables. Basically, variables are measurable parameters. And whenever you want to collect the data, you have to transform your research problem into measurable parameters because your research problem is just crude concept. It is not measurable item. You have to transform that research problem into measurable items or parameters, and those are called as variables. To measure the variables, we require certain measurement scale. And in the previous lecture, we discussed about four types of measurement scale. That is nominal scale, ordinal scale, interval scale, and ratio scale. In today's lecture, we will move to the next step of your research process that is called as hypothesis. Now, in today's lecture, we will discuss about constructing hypothesis under these heads. First is what is hypothesis, functions of hypothesis, methods of testing hypothesis, formulation of hypothesis, types of hypothesis, errors in testing the hypothesis, and hypothesis in qualitative research. Now, what do you understand by word hypothesis? Basically, whenever we start our research work, we have certain tentative idea in mind, tentative proposition in mind. Now, when I started my research problem was I wanted to see whether electric vehicles are really effective in reducing air pollutants or not. So that was an idea because I saw many electric vehicles on the road. So I was wondering whether these electric vehicles are really helpful in reducing air pollutant. So my hypothesis is that since there are so many vehicles which are seen on the roads and the government is also promoting electric vehicle, my hypothesis, my proposition, my assumption, my assertion is that electric vehicles are helpful in reducing air pollutants. Now, this is a just tentative proposition. This is my feeling. What I feel, I have just put on the paper, but it is not tested. It is not tested by me as a principal investigator. I don't know its validity. I don't know whether this statement or whatever I am thinking, whether it is true or false. So when we put up hypothesis, we do not aware about its validity. We do not know whether it is true or false. It is just a tentative proposition. It is just an assumption. It is not a tested. Okay. And in next processes or next research processes, we test this hypothesis. So it is a tentative proposition. Its validity is unknown. Validity means its truthfulness, whether it is true or false. So my hypothesis, whether electric vehicles are really helpful in reducing air pollutants or not. So this validity is unknown. I am not aware whether this statement, this proposition is true or false because I have not yet tested. It is just my thinking. It is just my proposition. In most cases, it specifies a relationship between two or more variables. Now, in my case, what I have taken two variables. First variable is vehicle, that is my independent variable, and second variable is air pollutants. So we have vehicles. Under vehicle, we have many vehicles like electric vehicle, hydrogen vehicle, CNG vehicle, petrol vehicle, diesel vehicle. So I can compare electric vehicle with any of these vehicles because if I want to test efficacy of electric vehicles in reducing air pollutants, I need to test against some known parameters. So nowadays we are using most of us are using petrol or diesel vehicles. So we know that because of that, there is elimination of lot of carbon particles or lot of PM 2.5 particle or lot of PM 10 particles. So I want to see whether the elimination of this particle is on the lesser side with the electric vehicle as compared to petrol or diesel vehicle. So basically here what we are testing, we are seeing the relationship between two variables, which variable independent variable as vehicle or electric vehicle against dependent variable as air pollutants like maybe PM 2.5 particle level, PM 10 particle level, carbon dioxide, sulfur dioxide. So all these are air pollutants. So we are testing the relationship between two variables. Like if electric vehicle is introduced, whether they are really helpful in reducing these air pollutants or not. I am seeing the impact of electric vehicle or impact of independent variable on the dependent variable, that is the air pollutant or association of electric vehicle on the air pollutants or the relationship between electric vehicle and the levels of air pollutants that we are testing. So coming to a definition, hypothesis is a hunch, assumption, suspicion, assertion, or idea. So basically it's a hunch. It's an assumption. You assume that. It is your assumption. It is my assumption. I am feeling that electric vehicles are helpful in reducing air pollutants. That is not yet tested. That is not yet, the data is not yet collected. It is just my assumption or suspicion or assertion or idea. It is just an idea about a phenomenon. Phenomenon means I am testing a phenomena of air pollution. Okay, so air pollution is going down. Similarly, during COVID, what we saw, the phenomena of reduction of reduction of spread of infection, COVID-19 infection, if we use mask, if we maintain social distancing, right? If we sanitize our hands repeatedly. So that was a phenomena. So that phenomena we tested against some independent variables, right? Or relationship or situation, the reality or truth of which you do not know. So hypothesis is nothing but it's an assumption. It's an assumption related to some phenomenon or relationship or situation, and the reality or validity or the truth of it is unknown. The validity is not yet tested. A researcher calls these assumptions, assertions, statements, or hunches as hypothesis, and they become the basis of inquiry. So what is the basis of your inquiry? These assumptions are basis of your inquiry. These assertions, these statements are basis of your inquiry, right? So what is my statement? I feel that electric vehicles are helpful in reducing the air pollutants. This is my assumption. Based on this assumption, I will further go and design my research. I will design my research in such a way that it will be helpful for collection of data. Okay, so I will have my dependent variables, and that is outcome variables. So I will measure the magnitude or outcome of those dependent variables after introduction of independent variable. And this is the basis. Hypothesis is the basis. My hypothesis, my assumption, my assertion is that electric vehicles are helpful in reducing air pollutants. My independent variable has its impact on dependent variable, that is air pollutants, and it will take it down, or the air pollutant levels will go down, or the dependent variable levels are will go down, right? That this is my hypothesis. Okay, any doubt in this, anyone? So this was the meaning of hypothesis, or what is a hypothesis. Now coming to the functions of hypothesis, the formulation of a hypothesis provides a study with focus. Whenever we start our study with a research problem, it's a crude concept, crude idea. At this point of time, when we start our study, when we propose a research problem, we are not totally aware what kind of variables we want to study. But when we propose the hypothesis means, in my case, what hypothesis I will propose, there is statistically significant reduction in the levels of air pollutant after introduction of electric vehicles as compared to petrol vehicle. This is my assumption. This is my hypothesis. Okay, so it is very clear. It is like I get a focus for my study. Now I know what I want to do. I want to test electric vehicles against petrol vehicles for checking their impact on the dependent variable, that is air pollutants. To be more specific, if you want to go, I can propose in this way. There is My hypothesis is that there is reduction in the levels of air pollutants, or there is reduction in the levels of PM 2.5 particle level after introduction of electric vehicles as compared to petrol vehicle. So it is more specific. You get a focus. You know what is your outcome variable, what you want to measure, right? What kind of impact you want to measure, or what kind of relationship or association you want to assess. That idea you get it, right? So that that is the function of hypothesis. So basically, the formulation of hypothesis provides a study with focus. So you are getting focus for your study. It tells you what specific aspects of a research problem to investigate. Now, what is your specific aspect of your research problem? I want to assess impact of electric vehicle on PM 2.5 particle alone. You have multiple particles, maybe PM10 or SO2 or NO2. So at this point of time, when I propose my hypothesis that there is no statistically significant difference, or there is statistically significant difference after introduction of electric vehicles in the levels of PM 2.5 particle levels as compared to petrol vehicles. So when I propose this
Yes.
way, it tells you what specific aspect of research problem you have to investigate. So I want to investigate PM 2.5 particle levels in relation to petrol and electric vehicles. Okay, so that is the first function of hypothesis. Now coming to next function, that is a hypothesis tells you what data to collect and what not to collect, thereby providing you focus to the study. Now, if I want to work only on PM 2.5 particles, suppose based on the literature, if I come to know that PM 2.5 particles are more hazardous as compared to other air pollutants, it is just for example. Okay, so what I will do, I will measure the levels of PM 2.5 particle rather than measuring all other particles. So now at this point of time, I know what I want to measure, what kind of data I need to collect. So what I have to collect, I have to collect the data of PM 2.5 particle after introduction of electric vehicles, right? And also I need a data on the petrol vehicles. So petrol vehicle before introduction of electric vehicles, when the petrols on the road are present on the road, at that point of time, first maybe for 1 or 2 months, I will collect data for with the petrol vehicles. Okay. After that, I will introduce electric vehicles and I will check the difference. Suppose with the petrol vehicle for 1 month, the average PM 2.5 particle level is 120 cubic millimeter. Then after 1 month, I will introduce the electric vehicles and I will see if the levels are going down, if the level is coming to 60 cubic millimeter, 50 cubic millimeter, then I can propose that there is 50% reduction in the levels of air pollutants as compared to petrol vehicle when I introduce electric vehicle. If it is increasing, then again, that is my finding. The levels are increasing by this much percent. So I got to focus. I got a tool for collection of the data. I know how I want to collect the data based on my hypothesis, based on the proposition of hypothesis. Since I have proposed this hypothesis, I know what is my outcome variable, what things I need to measure. So I know what to do. I get a focus for my study. Next function is as it provides a focus, the construction of hypothesis enhances objectivity. Definitely, when I say a research problem, it is totally subjective, right? If I say that I want to assess electric vehicles against air pollutants, whether they are helpful in reducing air pollutants or not. So there are so many questions whether I want to, there is a lot of subjectivity. Some of you will think that I want to test electric vehicles against electric vehicles against petrol vehicle. Some of you will think that electric vehicles against diesel vehicle or electric vehicles against CNG vehicle. So it is not clear what I want to test. What I want to test means there is subjectivity. Everybody will have their own thinking. When I have a research problem in mind, when I propose a research problem, it's a crude idea, it's a crude concept, it's just a idea. Okay, it is not a dissected into your variables. But when I dissect into variable and when I propose hypothesis, then I get objectivity. Now, if I propose a hypothesis like there is significant reduction or there is statistically significant reduction in the levels of air pollutants after introduction of electric vehicles as compared to petrol vehicles. Okay, so you are getting objectivity. Objectivity means all of us are on the same platform. All of the understanding of all of us is the same. Whatever you are understanding, everybody is understanding the same. That I want to test electric vehicles against petrol vehicles in the reduction of air pollutants. Or if you view more objectivity, then you can say that there is a statistically significant reduction in the levels of air pollutants rather than saying air pollutants. Suppose I want to measure only PM 2.5 particle level. I can convey that way also. There is statistically significant reduction in the levels of PM 2.5 particle level after introduction of electric vehicles as compared to petrol and diesel vehicle. So it is more objective. You get that there is no subjectivity. There is no deviations in the understanding among different people. Understanding is unanimous. Everybody will understand the same meaning. So there is objectivity in understanding the project, understanding the idea, understanding the concept. And that is because of your hypothesis when you propose the hypothesis. A hypothesis may enable you to add to the formulation of theory. Means you can come up with some theory. So it is helping me. Like if I say that there is a statistically significant reduction in the levels of air pollutants after introduction of electric vehicles as compared to petrol vehicles. So I am coming up with some theory that electric vehicles have its impact on air pollutants in reduction of these air pollutants. So that is a theory. You are coming up with some theory because you are testing this hypothesis. You are testing your hypothesis and you are going to prove or disprove your hypothesis. Based on that, you can come up with a theory, your own theory, like whatever you feel, whether it is true or whether it is false, whether that was valid or that was not valid. Okay, so you are testing the validity, and after testing validity, you will come up with your own theory. That I will come up with my theory that electric vehicles will helpful to reduce 50% pollution or 60% solution or 90% air pollutants or levels of air pollutants. So that is formulation of theory, and this hypothesis will definitely help you because you are going to either prove or disprove your hypothesis. It enables you to conclude specifically what is true and what is false. So definitely you will come to know what is true and what is false. Whatever my assumption that there is statistically significant reduction in the levels of air pollutants after introduction of electric vehicle, whether it is true or whether that is false in comparison to petrol vehicle. Suppose this is my assumption that there will be statistically significant reduction. But after collection of data, if I find that because of electric vehicles, the levels are increasing, then that is a false. If levels are decreasing, then my hypothesis is true. Then my assumption is true. My hypothesis, whatever is proposed, is true. So I can differentiate between true and false things. I can differentiate between validity. I can have validity of that particular thing. Okay, so hypothesis has that function that it helps you to formulation of theory, and it will help you to conclude specifically what is true and what is false, what is valid and what is not valid. Right? So that is the introduction of hypothesis and functions of hypothesis. Any doubt on this, anyone? Next, how do you process this hypothesis, or how do you test this hypothesis? So testing of hypothesis has 3 steps: phase 1, phase 2, and phase 3. In phase 1, you formulate your hypothesis, you formulate your assumption or hunch. So I have formulated my hypothesis. Like my hypothesis is that there is statistically significant or there is significant reduction in the levels of air pollutants after introduction of electric vehicles as compared to petrol or diesel vehicles. So in phase 1, you are proposing your hypothesis. In phase 2, what you do, you collect the data. Now, based on this, I know my independent variables, I know my dependent variables, I know my study design. Means I will propose study design. Like immediately after phase 1, you will not start collection of data. You will propose the study design. Based on the study design, you will collect the data, right? You will propose the methods of data collection, and based on the methods of data collection, you will collect the data. And in phase 3, you will analyze that data so that you will come to know whether whatever is your hunch or your assertion is true or false. So it has 3 phases. It has 3 phases means it covers entire your research project, right? So you have your research problem, and that research problem you have dissected into variables and measurement scales. Based on that, you will propose the hypothesis. That is the first phase, proposition of hypothesis, or putting a hypothesis in the form of scientific based on the scientific literature. So you formulate hunch or assumption. Next phase is you get your research designs into place and methods of data collection into place and collect the data. And in phase 3, whatever data is collected, you analyze the data. You apply certain test of significance so that you will come to certain conclusion. Based on conclusion, you will come to know that whether your assumption is true or false. Means you will get answer to your research problem. So basically everything is to find out answer to your research problem, right? So these are the steps in testing the hypothesis. Any doubt in this, anyone? Now, what are characteristics of hypothesis? A hypothesis should be simple, specific, and conceptually clear. So simple, specific, and conceptually clear means everybody should understand it. There shouldn't be any subjectivity or ambiguity when you propose the hypothesis. Now, when I am saying that there is statistically significant reduction in the levels of air pollutants after introduction of electric vehicles as compared to petrol vehicle, when I am putting this hypothesis, it's a simple hypothesis, simple to understand. What I want to say, I want to say that electric vehicles will helpful in reducing air pollutants as compared to petrol vehicles. This is the simple message I want to give. It's very specific. I am talking in terms of specific variables. I have a specific variables like petrol and electric vehicles as my independent variables and air pollutants as dependent variable. So it is very specific. It is not subjective. It is objective in terms of preparing the methods of data collection, and conceptually clear. My concept is clear. It is based on certain understanding. My concept is that electric vehicles are helpful in reducing air pollutant, right? So it should be conceptually clear. There shouldn't be ambiguity or subjectivity in its understanding. So your hypothesis should always be simple, specific, and conceptually clear so that there shouldn't be any subjectivity. It is always objective in terms of collecting the data and analyzing the data. A hypothesis should be capable of verification and re-verification. So whenever I am proposing this hypothesis, suppose I am testing this in Navi Mumbai area, someone else should be able to test in different parts of the India, different parts of the world, right? Suppose I am testing here and nobody in the world is able to test my hypothesis, then it is difficult. It is not re-verifiable. There is no validity. There is no re-verification. There is no reliability of my research work. If I want to add reliability of my research work, if I want to have verification of my research work, the same research work under similar condition should be repeatable, right? So you have your hypothesis in such a way that it should be re-verifiable, it should have reliability, it should have a validity. A hypothesis should be related to existing body of knowledge. So there should be some existing body of knowledge, right? Because existing body of knowledge will help you to arrive certain yes and no's. Okay, existing body of knowledge will be able to help you to identify the gaps in the literature. So based on the gaps, you will work on those areas, only on those variables where the gaps is present, so that you will be able to add something new to the existing body of knowledge. So your hypothesis should be related to existing body of knowledge. There is a lot of literature related to electric vehicles and air pollutants. So I can refer that existing body of knowledge, and wherever it is lacking, I can work on those areas, or whatever is the gap, I can work on those areas. A hypothesis should be operationalizable. It should be doable. Like suppose I am proposing certain hypothesis, and if I am not able to convert it into research project, if I am not able to convert it into measurable parameters of, or if I am not able to measure the parameters which are associated with my study, then it is not workable. You will not get answer to your research problem. So your research hypothesis, research problem that is converted to research hypothesis should be such a way that it should be operationalizable. It should be measurable. You should be able to do it. Okay. So it should be feasible in terms of completing your research project or getting answer to your research problem. So these are some of the characteristic features of the hypothesis. Okay, so whenever you propose hypothesis, you just remember these points, that it should be simple, specific, and conceptually clear. It should be capable of verification. It should be related to existing body of knowledge, and it should be operationalizable. So these are few of the points which are essential to propose hypothesis. Okay, now coming to the types of hypothesis. Classically, we have two types of hypothesis. First is null hypothesis and second is alternate hypothesis. Now, null hypothesis means null means no, hypothesis of no difference. And alternate hypothesis means hypothesis of difference. So whenever you propose hypothesis, at this point of time, you are not aware of its validity. Now, what I am proposing, I am saying that there is statistically significant reduction in the levels of air pollutants, or there will be statistically significant reduction in the levels of air pollutants after introduction of electric vehicles as compared to petrol vehicles. This is my hypothesis. This is my assumption. This is just assertion. I have not yet tested at this point of time. So if I take this alternate hypothesis and if I try to test it, it is my assumption. It is on the positive side, right? So what I should have a neutral aspect. Whenever I start a study, I shouldn't go with some things in mind, like based on some previous literature or based on some previous experiences. You should start your research project with a neutral idea. So what is that neutral idea? Hypothesis of no difference. Electric and petrol vehicle, like there is no significant difference in the levels of air pollutants when you compare electric and petrol vehicle. That is a null hypothesis, means there is no difference. At this point of time, you can test this null hypothesis, whether it is true or false. If you find the difference, you will say that you will reject null hypothesis. Okay. And if there is difference, sorry, if there is difference, you will reject your null hypothesis. And if there is no difference, you will accept your null hypothesis. Okay. So null hypothesis means hypothesis of no difference. There is no difference in the levels of air pollutants in electric and petrol vehicles when you compare electric and petrol vehicles. So that is my null hypothesis, that hypothesis of difference. Okay. So what is null hypothesis? It is a hypothesis of no difference, that there is no difference in the levels or there is no difference in proposed parameters. No statistically significant difference. So this word is important, that statistically significant difference. So you should be able to find out certain statistically significant difference to prove your alternate hypothesis. So researcher tries to disprove the null hypothesis. So what we test, we always test our null hypothesis. We do not test null alternate hypothesis. Why? Because it's a null hypothesis. It's a neutral hypothesis. It's a starting point, because at this point you have not collected data. It is a point where you start collecting data or you start designing your research, right? So you start with a neutral approach. Always you as a researcher, whatever is your assumption, whatever is your hunch, that is just your assumption. That is just your concept or idea. Okay, so how do you test it? You should be neutral when you are testing it. So how will you be neutral? You will be proposing null hypothesis, that there is no difference, and you will test that whether there is difference or not, no difference. Like you will test your null hypothesis. You do not test your alternate hypothesis. Always remember that you always test your null hypothesis for your study, right? Because it is a neutral starting point of your research problem. Okay, or collection of data for your research problem, right? So researcher tries to disprove the null hypothesis. So what is in my mind? I want to prove my alternate hypothesis. For that reason, I will collect the data and I will try to disprove. Okay. Based on the statistical considerations, I will try to disprove the null hypothesis. And it is denoted by H0. So there are in the literature, null hypothesis is denoted by H and 0, small 0. So whenever you write your null hypothesis, you can write H0 as there is no statistically significant difference in the levels of air pollutants when we compare electric and petrol vehicles. Okay, so that is my null hypothesis, right? So there is no statistically significant difference. The difference is not significant or it is not statistically significant difference. Now, next hypothesis is called as alternate hypothesis, or it is my study hypothesis, or it is my scientific hypothesis. Whatever I feel, whatever is my assumption is that is alternate hypothesis, and it is called as hypothesis of difference. So in here, what I will propose, there is statistically significant difference in the levels of air pollutants after introduction of electric vehicles as compared to petrol vehicles, right? So that is the alternate hypothesis, means there is the hypothesis of difference. It is not neutral, it is on the positive side. For this particular hypothesis, it is a positive aspect that I am saying that there will be reduction of air pollutants after introduction of electric vehicles. And I do not test this hypothesis. I always test the null hypothesis, because alternate hypothesis is always my assumption. I will try to prove my assumption based on the what? Based on the study of null hypothesis. So I will study the null hypothesis. I will collect the data to reject the null hypothesis. If I reject my null hypothesis, means I will accept my alternate hypothesis, right? When you reject your null hypothesis, you will accept your alternate hypothesis, means whatever is your original hypothesis or study hypothesis, that will be accepted. So it is hypothesis of difference, statistically significant difference, and it is not by chance. So whatever difference you have received, whatever difference you have measured, that difference is not by chance. It is actual difference. It is statistically significant difference, and it is not by a chance. It is actual difference. Researcher try to approve the alternate hypothesis, or I will try to prove my alternate hypothesis, because this is my assumption. This is my assertion. So I will try to prove it. Okay, and I will try to reject my hypothesis based on the collected data. Alternate hypothesis is denoted as H1 or H alpha. So you can either denote as H1 or you can denote it as a H alpha, right? So alternate hypothesis is H1 or H alpha, and this hypothesis, null hypothesis, is H0, right? So did you get the point? What is null hypothesis and alternate hypothesis? Any doubt in null hypothesis and alternate hypothesis? So whenever you propose hypothesis for your research, first will be your H0, that is null hypothesis, hypothesis of no difference. And you prove this or you disprove this, you work on your null hypothesis, right? And second is your alternate hypothesis. That is whatever is your assumption that electric vehicles are helpful in reducing the air pollutants as compared to petrol vehicle. That is my assumption. That will come under alternate hypothesis. And null hypothesis will be there is no significant difference in the levels of air pollutants even after introduction of electric vehicles after when we compare with the petrol vehicles, right? So that is a null hypothesis, that hypothesis of no difference. Now errors in testing hypothesis. See, whenever we are proposing hypothesis, we are working in real world. We are working with real life situations. So when we are working with real life situation, we cannot control all the variables. We cannot control all extraneous variables, or we cannot control random or chance variables, right? So these are the variables which try to introduce errors in your study. In details, again, we will discuss under research statistics, the different aspect of errors in hypothesis. But under research methodology, we will discuss about research methodology aspect of errors in testing hypothesis. Now, why do we introduce errors? Because we are working in real life situation. When you work under certain laboratory experiments, like when you are conducting laboratory experiments, you can control the environment, you can control the temperature, you can control the humidity, you can control most of the parameters. But in outside world, in real world, when you are dealing with the human population, when you are dealing with the animal population, you cannot control somebody's emotions, you cannot control somebody's perception, you cannot control the thinking of your population. It is not always in your hand. Okay, you cannot also control many phenomena or situations, right? So there is a possibility of introduction of errors because of these extraneous variables which are always present, and they try to influence your dependent variable. Apart from these extraneous variables, we have certain other random variables or chance variables. They also try to introduce certain errors in your study. Okay, so we never say that I am 100% confident about my results. We say that there is possibility of 5% error, there is possibility of 10% error. So whenever you do this research work, you propose a p-value. What is this p-value? P-value is probability value. It is alpha error. It is type 1 error. So whenever you propose your alpha error, type 1 error, you always say that there is 5% possibility of error in my study. I am 95% confident whatever results are there. I am 95% confident that these results are correct results. Only there is 5% possibility of errors in my study because of these extraneous variables, because I am not able to control it to fullest extent, right? Because of that, there is an error and it is acceptable up to certain limits. Up to 5 to 10% error is accepted. That is type 1 error. So whenever we propose p-value, probability value, you must have gone through your master's program. During your writing thesis or during writing the papers, you propose a p-value, whether it is statistically significant or not. So what is 0.0? P-value is always 0.0. Most of time we propose at 5%. If you propose it at 10%, then it becomes 0.10. So 5% means 5 divided by 100. That is 0.05. So p-value is, that is type of error, type 1 error. How much type 1 error is acceptable for your study? So you first fix it. When you start your study, you fix that this much of error. I will accept 5% error, or I will extend it up to 10%. Most of time we fix it for 5% of error. You can fix it for 1% also, or 5% also, or maximum up to 10% of type 1 error. Okay. So why errors occur during testing your hypothesis? The study design selected is faulty. Suppose you require X study design and you are selecting Y study design. The next chapter will be study design. So in that you will understand details of all study designs which are used in quantitative research and qualitative research. So suppose you require X study design and you are applying Y study design for your study, or Y study design is not suitable for your study for collection of particular data, then there is a possibility that you will introduce error in your study. The sampling procedure adopted is faulty. Sometimes what you do, based on your convenience, you try to enroll the population, but it is not always uh, uh, accepted. Like sampling should be, every person in the population should be given equal opportunity. Suppose there are 30 people in this batch and I want to conduct one research, or I want to have some research related problem and I want to collect data from your batch. I should not do convenient sampling because I know these people. Like there are few people who have registered from university also. So I know those people. If I purposefully select those people, or if I know that these people are intelligent and I will select for studying these people, then it is a purposive sampling. That is not accepted. All 30 people should get equal opportunity to be a part of study. Okay. So when you do that way, this sampling procedure is acceptable sampling procedure. All these details we will discuss under sampling procedures when we will talk about sampling procedure chapter. So sampling procedure should not be based on your convenience, based on your selection, based on your uh, liking. Like suppose if I like somebody, I should not select that. It is based on the randomization. Randomly you should select. Randomly means each and every person in a population, each and every person in a batch should get equal opportunity of getting selected for this particular research project. If I purposefully select, then it is not random sampling procedure. Okay, so try to apply a random sampling procedure to minimize errors in study. If you if you apply purposive sampling, then there is a possibility of errors in your hypothesis. It is accepted for qualitative research, but for most of quantitative research, try to apply random sampling, and the details will be discussed under sampling chapter. Okay, there is separate chapter on the sampling procedure. The method of data collection is inaccurate. If the method of data collection, whatever you have applied, may be based on your, basically it's a research tool, it's a data collection tool. Questionnaire is also a tool. Okay, you require a questionnaire and you are using some other method of data collection. So in that case, it is not acceptable. So data collection is always your data tool or collection tool, and that data collection tool should be accurate for getting answer to your research problem. It should match with your objectives. It should go hand in hand with your hypothesis. If it is not matching with your objective, if it is not matching with your hypothesis, then you will get errors in your study. The analysis is wrong. Now, during analysis, what we do, we know certain tests and we try to apply those tests. See, for analysis, data is most important part. The variables and measurement scales in the data, whether data is parametric data or non-parametric data, that you have to first decide. So you know parametric test, so you are applying parametric test. It is that way it is not acceptable. Okay, if your data is not following all the standards of parametric data, if all the procedures of parametric data, then you should go for non-parametric test. Okay, so there are different types of tests, parametric test and non-parametric test for quantitative data. So before applying, you should see whether it is fitting into which category, whether it is in accordance with the parametric data or whether it is in accordance with the non-parametric data. If it is fitting into non-parametric data and you are applying parametric test, then you will bound to have errors in your study. If that data requires non-parametric test, go for non-parametric test. Okay, if data is fulfilling all the requirements of parametric data, then go for parametric test. So we will discuss again this in details under parametric and non-parametric test in detail. The statistical procedures applied are inappropriate. Again, the test of significance, I told you, like there are different tests of significance. Okay, test of significance for parametric data, test of significance for non-parametric data. Like non-parametric data, we have chi-square test, or parametric data, we have t test. Okay, or pair t test. So you have to select appropriate test. You have to select correct test. If your test is wrong, it is going to give wrong results. See, you test your hypothesis or you test your data, you applied this test of significance in certain softwares. You use SPSS software or Minitab software. Whatever data you are feeding, software is just giving response. It is not going to analyze for you. It is just giving the results. That result you have to analyze. Okay, you have to see what are those results and whether those results are correct or wrong based on what is expected, what was the research problem, what was the research hypothesis, what was the method of data collection. So everything should match for your final conclusion. Okay, so that is important. Statistical procedure, test of significance, whatever you apply, that is important. Conclusions drawn are incorrect. Many times what happens, you apply the test. See, I told you, like software will not conclude you. Software will give certain figures. Okay, maybe p value is this, Mann-Whitney value of this particular is this, pair t test value is this much, test of significance or p value is this much. So this is given by the software. This is given by certain statistical procedures or statistical calculations. You have to conclude. You have to conclude as a researcher, as a principal investigator, you have to conclude what is the meaning of that outcome. If you are getting chi-square particular value and p value as a significant or non-significant, you have to conclude. You have to conclude on your own. The software will not conclude. It will just give the results. It will just give the values. So you are the one who is concluding the results of that outcome, whatever outcome is given by the software. Okay, so that conclusions, if drawn are incorrect, then there is errors in testing your hypothesis. Now coming to next important part, different types of error, and you need to understand errors in the study. So basically we have two types of error. One is type 1 error and second is type 2 error. Type 1 error is also called as alpha error and type 2 error is called as beta error. So whenever we start study, we propose our type 1 error. So type 1 error is proposed at the beginning of study. Before data collection, we propose that for this particular study, I propose 5% error. I propose 1% error. I propose maximum 10% error. Okay, so that is the limit that accepted for type 1 error. Okay, and type 2 error you control. You control by applying different parameters. You control by controlling your extraneous variables, your random variables, your chance variables. Now among type 1 and type 2 error, what is exactly meaning of this type 1 and type 2 error? So here I have written type 1 error is rejection of null hypothesis when it is true. And type 2 error is acceptance of null hypothesis when it is false. So when we read this, it is slightly confusing, right? From this, it is difficult to come to some conclusion or it is difficult to understand. For understanding, I will give you two examples, real life examples to understand what is meant by type 1 error and what is type 2 error and what are its implications when you are doing your research project. See, the errors in your study are the most important aspect. You should control the errors, but which is the most important error for your study? When you are conducting study, you should understand which is the most important error. Ideally, you should control all the errors in your study, right? But which is the most important error which has some implications in terms of or serious implications. So it is based on few examples. I have taken two examples here. The first example is related to a fire in the building. Now, those people who are staying in Mumbai, generally they stay in multi-story buildings. So in Mumbai, there are no separate flats, there are no separate row houses or separate houses. These are multi-story buildings, and in these multi-story buildings, there are fire alarm systems. So at each floor, there is fire alarm system, because if the building is 30 floor, 20 floor, 35 floor, then you should have alarm at each floor if there is fire breakout in the building. Now, suppose I am sitting on a particular floor, maybe 15th floor, 16th floor of my building in my living room, and I smell a smoke that is coming from somebody's flat, okay, the nearby flat. Now, there are two possibility. What I will think, the first possibility is that I will think that this smoke is not a serious thing and it is coming from somebody's kitchen. That is first possibility. Or second possibility is that I will think that this smoke is something serious fire. There is some serious fire in the building and that smoke is coming from that serious fire. So these are the two possibilities. So what is my conclusion? I can conclude that there is serious fire in the building. That is first possibility. Or I will conclude that there is no serious fire in the building and the smoke is coming from somebody's kitchen. These are my conclusion. There are again two actual conditions. Means this is my conclusion. But actual condition, maybe there are also two possibility. First possibility may be there is serious fire in the building and there may not be a serious fire in the building. This is the actual condition. Actually, what is happened? I am sitting in the room. I am not seeing anything. Just I am having this smell of this smoke which is coming from somebody's flat. Now coming to first conclusion. First conclusion is serious fire. What is your null hypothesis here? Your null hypothesis is that there is no serious fire in the building. Suppose I want to study this as a research project. So my null hypothesis will be a hypothesis of no difference. Means there is no serious fire in the building is my null hypothesis. And my alternate hypothesis is there is serious fire in the building. Now I am sitting in my living room and I will come to my first conclusion. My first conclusion is that there is serious fire in the building. So what I am doing here, I am accepting my alternate hypothesis and I am rejecting my null hypothesis. Okay, what I am doing, my null hypothesis is that there is no serious fire in the building and alternate hypothesis is that there is serious fire in the building. Now coming to first possibility, I am thinking that there is serious fire, there is somewhere serious fire in the building. Means I am accepting my alternate hypothesis and I am rejecting my null hypothesis. So what are its implication? In first case, now this is my conclusion. Now actual condition, I am thinking that there is serious fire in the building, and if actually there is serious fire in the building, what I will do? Even in this case, even if there is no actual fire, what I will do, if I am thinking that there is serious fire in the building, I will switch on the fire alarms. I will inform all the other flat members. I will inform all other society members that there is serious fire in the building. You evacuate the building. Simultaneously, I will call the fire brigade. I will inform the fire brigade that there is serious fire in the building and you come as early as possible. So what will people do? People will evacuate entire building. People will go down. Okay, people will leave the building and the fire brigade will come into picture. Suppose if there is serious fire, I am correct. There is no mistake. Means I am doing my assumption, my conclusion is correct. The fire brigade will take care of the fire. But the second possibility, that actual second possibility, is that there is no serious fire in the building. While sitting in the living room, I am thinking that there is serious fire in the building. But actual condition is that there is no serious fire in the building. Since I am thinking that there is serious fire in the building, I will call all the people. I will ask them to evacuate the building. I will call fire brigade and I will ask them to come here. Now, what is happening? Actually, there is no serious fire in the building. The smoke is coming from somebody's kitchen. But everyone has evacuated the building. Fire brigade has come into kitchen and they are now searching. And finally, they found that there is some smoke that is coming from somebody's kitchen. What has happened here? It is just inconvenience caused to everyone. There is inconvenience caused to all the society members, inconvenience caused to fire brigade. Okay, that is my type 1 error. Now coming to second condition or my second conclusion, that no serious fire in the building. Means here what I am doing, I am not rejecting my null hypothesis. I am accepting my null hypothesis and I am rejecting my alternate hypothesis here. Okay, that is second possibility. I am sitting in my living room. I smell a smoke and I think that, or I conclude that whatever fire is coming, it is not a serious fire and it is coming from somebody's kitchen. So what I will do, I will not take any action. I will not switch on fire alarm in this condition. I will not inform people. I will not ask to evacuate the building and I will not call the fire brigade. But what is the actual condition? The first possibility that there is serious fire in the building. In this case, I am committing type 2 error or beta error. I am thinking that there is no serious fire in the building. I am not informing people. I am not switching on the alarm. I am not calling fire brigade. But actually, there is serious fire in the building. What will happen? The fire will increase. The people will lose their lives. Okay, there will be loss to building structure. Loss to building structure you can recover, but loss to life cannot be recovered. Once there is loss to life, you cannot recover it. So in real life situation, beta error will have its implication. In implication here, the implication will be loss to life, loss to property. Loss to life is not at all acceptable. So when I am committing such kind of error, that is beta error or type 2 error, it has life threatening complications. So whenever you are conducting study, if you are committing type 2 error in your study, it will have some kind of life threatening implications. Suppose you are a you are a medical healthcare worker and you are testing one drug. If the wrong drug comes to the market, if you commit type 1 error, the drug will not work. There will be no action of that drug against particular disease. That is acceptable. You will have alternate drugs. But if that drug is causing death of people, see in the literature this has happened. There are so many examples in the literature that people have committed type 2 error while getting drugs in the market and people died. So outcome will be death. And these are life-threatening situations. Okay, life-threatening complications. So in real life situations, type 2 errors are more fatal. Type 2 errors are more dangerous as compared to type 1 error. Type 1 error, what is happening in this case? I am thinking that there is serious fire in the building. I am asking everybody to evacuate building. I am calling fire brigade. Fire brigade is coming, and that is just inconvenience caused to everyone. Nothing else. That is type 1 error or alpha error. But in second situation where I am thinking that there is no serious fire in the building and actually there is serious fire in the building, I am committing type 2 error because of I am not switching on fire alarm. I am not calling fire brigade. I am not asking people to evacuate building. And in this case, the people will lose their life. People will lose their property. Okay, there will be loss to life, loss to property, and that is type 2 error. Okay. There is one more example, a COVID situation. Suppose you are in COVID era 2020, go back to your COVID era. One fine day, suppose I have a temperature or I feel that there is temperature. So I will approach my physician. I will go to my family physician. Now, again, when I go to my family physician, there are two possibilities. My family physician will think that I am suffering from COVID-19 or coronavirus infection. And second possibility that my family physician will think that I am not suffering from COVID-19 or coronavirus infection. Again, there are two actual condition possibility that actually this is the conclusion of my family physician or doctor. But actual condition maybe there are two possibility that I am suffering from COVID-19 infection or second possibility is that I am not suffering from COVID-19 infection. Similarly, we have null hypothesis and alternate hypothesis. Now, in this case, null hypothesis is that the fever is not due to COVID-19 infection. That is my null hypothesis. And alternate hypothesis is that fever is due to COVID-19 infection. Now, first conclusion of my family physician is that fever due to COVID-19 infection means he is rejecting null hypothesis that there is no COVID-19 infection. That is my null hypothesis. When my family physician is concluding that this fever is due to COVID-19 infection. So what he will ask me, he will give me certain medication. He will ask me to isolate myself. He will ask me not to meet to my family members. Okay, means I will be isolated. I will not go to office. I will not go to market. I will not go to any other place. I will not meet my friends. I will not mix with people for next 10 to 15 days. Okay. Suppose the actual condition is fever due to COVID-19 infection, then he is correct. My family physician is correct. His diagnosis is correct. And that is fine. Whatever he has prescribed is correct. But if he is thinking that this fever is due to COVID-19 infection and actual condition is the fever is not due to COVID-19 infection, it is because of some other viral infection. But what he has done, he was thinking or my family physician concluded that this fever is due to COVID-19 infection. He has given me certain medication. He has asked me to remain isolated. He has asked me not to go to office or not to go to market or not to mix with my friends. So I am doing this for next 14 days. What is happening? There is inconvenience which is caused to me and my family. There is nothing extra. I got isolated. I'm not going outside. I am not going to office. Okay, I am sitting in one room and isolated myself. Means there is inconvenience caused to me. There is inconvenience caused to my family members. If the doctor is committing type 1 error. Okay. But suppose if doctor is committing type 2 error, how will he commit type 2 error? Second possibility. Suppose I go to doctor, doctor thinks that no, this fever is not due to COVID-19 infection, it is some viral infection. So what he will do, he will prescribe certain medications, he will ask me to go home, he will not restrict me from mixing with the people. So he will just say that this is not COVID-19 infection. I will also be happy. I will go home. I will mix with my family members. I will go to my friends. I will go to market. I will come to office if I'm feeling better. And I will keep infecting many people. Okay, I will go home. I will infect people from home. If I go to market, I will infect so many people. If I meet my friends, I will infect those friends. If I come to office, again, I will infect the office staff. Means I am infecting people multiple times. If doctor is committing type 2 error, means he is thinking that the fever is not due to COVID-19 infection. And actual condition is that fever is due to COVID-19 infection. So what is the implication? In real life, I am infecting so many people, 300, 400 people. And again, those 300, 400 people will again infect 300, 400 people. So the spread will keep on increasing. Okay, means because of type 2 error, which is committed by my family physician, there is real life implications. Means there are actual consequences in the form of infection of so many people. So type 2 error is more fatal. Type 2 error is more dangerous in real life situation as compared to type 1 error. Okay, type 1 error you propose initially. Okay, type 1 error, like whenever we'll go to the statistic lecture, that time you will come to know how to have your confidence limit, how to identify your confidence limit and propose type 1 error. Type 1 error we propose at the beginning of study. Yeah, as in during proposition of null hypothesis. And type 2 error we try to control by adding controlling group, by controlling extraneous variables, by controlling random variables, by controlling chance variables. Again, those things we will discuss in research design, because in research design you have to control all these. Type 1 error is proposed by you. Type 1 error is said by you, or type 1 error is given by you at the time at the beginning of the project. But type 2 error you have to control. Type 2 error of your study you have to control by controlling errors in your study, like the errors which are contributed by extraneous variable, random variable, chance variable, or some other activities. So all that you have to control during your research project. So under research design as well as during statistics, we will discuss this in detail, how to control it. Okay, so whenever you propose a research design, you have to control it. Type 2 error we have to control. Type 1 error we have to fix to certain limit, and type 2 error you have to control from your study by having proper research design, by introducing the control group in design, by eliminating extraneous variables, by controlling random variables. So under research design, we will discuss how to control your type 2 error of the study. Okay, or how to control errors in your study.